Hello and welcome to Command and Control using Sliver, the fourth episode as part of our Red Team Fundamentals mini-series. In this video, we'll be taking a look more closely at the whole concept of Command and Control, understanding its basic architecture, infrastructure, why it's important, but most importantly, we'll be taking a step from our theoretical content that we've covered in the previous three videos, and we'll be getting some good hands-on usage of a command and control framework, that will set the stage for all subsequent videos that are to come. So in this video specifically, we will be setting up Sliver, if it wasn't clear enough, as our command and control framework. But we'll be going through its installation. So we'll be setting up the client, the server, and we'll be going through its fundamental usage, generating payloads, or also known as implants, communicating with compromised victims, using Sliver with fellow Red Team operators, and overall just getting a good understanding of what it's like to use a command and control framework and Sliver itself. Now, one thing to note is that obviously not every single functionality of Sliver can be covered in a single video, let alone for somebody who may just be getting into the realm of red teaming. So as you progress throughout our mini course, as you get onto the modules of persistence, privilege escalation, you'll progressively build your Sliver toolkit and progressively learn more about it. So really this video focuses more on the fundamentals, how to use it, and the subsequent videos will cover it more in depth. My name is Tennis, and if you enjoyed this video, make sure to leave a like and feel free to join our Discord server, for which link to I've left in the description below, to keep up to date with our content and some really exciting stuff we've got coming up at HackerForce. Now, as you begin your red team assessment, one of the things that you might immediately notice is that trying to maintain access over multiple hosts at one time can really become tricky. Most of the time, you'll require persistent connections to the hosts in order to carry out your operations and ultimately achieve your end objective. So instead of directly engaging with the compromised systems, whether that's through many different open terminals or something similar, a command and control framework functions as that consolidated platform for communications with and management of compromised systems. And one thing to note here is that this management, all of this management is typically done through secure, covert channels that utilize obfuscation, encryption techniques, to execute instructions and retrieve their outputs. So a command and control framework not only provides a centralized interface for all your management tasks, but it also does so in a way that it's discreet and can even evade blue team's defenses. If you've never used a command and control framework before, you might not immediately grasp its benefits. However, just note that without it, trying to manage multiple hosts can not only be very tricky, but also time-consuming, error-prone, and overall just an unpleasant experience. So in a typical red team command and control framework infrastructure, you'll have three main components. You're going to have the client, the server, and the agent. Now, the client is something that is installed on the operators, that is your system, and it provides an interface with the server to interact with the compromised hosts, create new payloads, implants, and much more. The server, on the other hand, functions as that centralized middleman who handles the communications between the client and the agent. And essentially all it is a central command hub for administering all the actions. Now, servers can be hosted in many different ways. You may see some servers being hosted on cloud infrastructure. So platforms like AWS, Azure, and these offer the benefits of blending in with regular traffic. However, they are typically more limited in the control that they provide, and also may be subject to legal restrictions. Additionally, and more commonly, you've got dedicated infrastructure. So these are self-hosted servers virtual private servers or VPSs, and these typically allow for more controlled and cloud infrastructure, allowing for complex setups with redirectors and other obfuscation techniques, but typically they may be detected by defenders more quickly. And lastly, you've got the agent, and really this is the software that sits on the compromised victim, communicating outbound to the server, and through the server then we can access that agent and run commands through it. So collectively, these three components constitute the operational foundation of a command and control framework. And all of these three enable red team operators to organize their operations and conduct their assessments. Now, there are many different frameworks available. In the table that you are seeing, in no particular order, I've highlighted the top 5 that I've used and found really good. So you've got Sliver, you've got Havoc, Empire, Metasploit, which is really beginner friendly, and Cobalt Strike. Now, the one you'll typically end up using will depend on the organizational requirements and your assessment needs. So maybe an organization might want to see how data can be exfiltrated through WireGuard or mTLS. In that case you might choose to use Sliver. But maybe there might be cases where an organization might want to use SMB, in which case you might use another framework. So typically the framework you use will depend on the requirements of the assessment, but we find that Sliver is the most versatile of them all. So before moving on to the network architecture of this course, I just quickly want to show you this website called C2 Matrix. It provides a lot of information about the available C2 frameworks, how to set them up, how to generate payloads, the modules. So it's a really good reference point when you want to learn more about a particular framework, quickly set it up and get it running. Now, the main thing here is the spreadsheet that is provided as part of the website, and it provides a comprehensive list of the available C2 frameworks, along with some information about them, such as their GitHub page, information regarding if it's supported on Kali Linux, the server language, the Implant language that it supports, its UI, whether it's command line or graphical user based, the available payloads it supports, the communication channels also, and the capabilities here. Now, the capabilities in particular here are good to kind of see, maybe you want a specific capability of, kill date, right? Maybe you're performing an assessment, and you have a particular time when the assessment finishes, and you want to ensure that every single implant is terminated. In this case, you would use a kill date, and you'd be able to filter down on the available command and control frameworks and really decide which one is best given your capabilities. So I'd really suggest that you go through this spreadsheet, explore the various command and control frameworks there are, go through their website, go through their repository, and really start getting a feel for what a command and control framework can bring. Now, one of the last things I want to note is that although this spreadsheet is very comprehensive and there's a lot of content, most of the stuff here is not really that updated anymore. So where you might be looking through a particular command and control framework, and it says it doesn't support a custom capability, or capability, that is, it's a matter of fact of going to the framework's website or repository and having a look there, because most of the time the feature will be there, and when this was written it wasn't, and it may have not have been updated. So remember, when choosing your command and control framework, really do your research on it. But as we continue along, we'll be using Sliver, so all of the research is already done for you. Now, before we get into setting up and installing Sliver, I've made a diagram that outlines the network architecture that this mini course will follow. Now, I understand that this may be confusing for some who may have never been exposed to such diagrams, However, for now, you don't really need to focus too much about it. To put it simply, we have a client, a server, and an Active Directory domain. The client will be interacting with the server, and the server will be handling communications between the client and the agents. That is the agents of Corp A domain. Now we'll make a video of how to set up this entire architecture a little bit later in this course, so you don't really need any of this to get started. In this video, we'll be installing the client and the server, with the server mimicking a VPS in the cloud. And more specifically, it will have two main interfaces. One of those interfaces will be exposed to our local client instance on 10.0.8, and the other will be exposed to our Active Directory domain on 10.0.9. Now, when either the client or the agent will be connecting to the server, this entire organization will make it appear as if the command and control server is being hosted in the cloud and is acceptable by two sources. Additionally, to follow along, you'll also want a Windows machine that is reachable by the server, as we'll be demonstrating what it's like to capture connections from our server and interact with them. And this is fairly straightforward to set up, and there are many resources online. However, just ensure that it is actually reachable by the server. Now, there is a much more simpler architecture you can follow. The previous slide may have been a little bit overwhelming, but essentially here we have two machines, and the client and the server of the command and control framework will be installed on one machine, and from that single machine all of our operations will be conducted from. And also you have a Windows machine, and all of this is connected on the same LAN, within the same IP range. And this is really good for, when you're participating in capture the flag exercises, having everything, from the client, the server, all on a single machine is very straightforward. And, as we'll soon see, to install it is very straightforward. But in a real world engagement, you typically won't see it like this. But again, for practice, it's really, really good. So what you're seeing now is Kali Linux. This is going to be our main operating system from where we will conduct all of our attacks, and from which we will be using Sliver. Now, the only changes I've really made was obviously updating the system. I've added my HackerForce user to the sudoers group. I've configured a terminal for readability, which you can see here. I'm running tmux. And tmux just will allow us to navigate the terminals more easily, and it will allow me to present the content in a much more digestible way. And I've also configured Vim for editing some files should we need to. Now, the changes that I've just mentioned are not necessary. You can just install Kali Linux and use it as it is. This is purely for video-based purposes, so don't really worry too much about it. And as for the server, the only changes I've really made was updating the system. You can see there that we are running Ubuntu server 2404 to be exact. And basically this is the server that we will use as our command and control server. So really it's that simple. Now, as I said previously, there's two ways you can install Sliver. One of those installation methods, which I'll showcase now, is installing both the client and the server on one machine. And there is also that second method where the client is installed on Kali and then the server will be installed on a Ubuntu machine remotely. So to get started, let's open up Firefox, and here we'll go to Google, so it's just a little bit easier. Yes, accept the cookies. And to find Sliver, all we got to do is Sliver C2. And one thing I wanted to show you earlier was the documentation that Sliver has. And this is their main page on everything that is to do with the Sliver command and control framework. They've got their own tutorials, which they probably do a better job than me. You got a set of documentations here. So you can, if you have any questions about the command and control framework, you can go to this documentation page here, and you'll probably find the answers for it. I'll leave a link to this page in the description below. But what we're going to do is we're going to go onto this GitHub repository, and if we scroll down here, we'll see a little README on the Sliver command and control framework, some highlighted features, multiplayer mode, staged and stageless payloads. Don't worry too much about them now, but what we are after is this specific Linux one-liner. Now what we're going to do is we're going to copy this command here, and actually instead of running it as it is, we're just going to remove this sudo bash. And what this did was pipe it to bash for install, but we're not just going to install it because I kind of want to iterate a very important lesson. So if we run this command here, what we'll see is a script for bash. And this script in particular will set everything up with Sliver, right? So it will set up Sliver depending on the type of operating system you're running, set up some GPG keys and everything like that. Now, one thing to note, and this is the important lesson, one thing to note is that running scripts like Sliver provided like this from unknown sources, it can be quite tragic. So always inspect your scripts when you're running commands like this, because there's been cases where, malicious actors have previously infected files like this and, got, unknowing users to install some malware. But don't worry about this. As of now, it's safe. So we're just going to run it. And what this will do is just, as I said, install Sliver completely on a single machine. So we'll just wait for it to finish, and we'll get back to it. So now that everything's complete, all that's remaining is to run Sliver, and bam, we are in the Sliver console, and that's it. That's all you need to do, and that is the easiest method for which you can get Sliver up and running. But again, you typically won't use this type of configuration in real-world engagements. So let's get to installing the client and the server separately. Now, installing it, separately with the client being installed on our Linux machine and the server being installed on a separate, Ubuntu machine, we will have to download the packages separately. Now, Sliver typically ships with a client package and a server package. To find these packages, you can just simply go to releases here on their GitHub repository. And here you'll see the numerous assets that are available. So all of these client executables here, they're different for each operating system that you may be using. And that's the best thing about, a command and control framework is that, regardless of whether you may use it from Mac OS, Windows, or another operating system, a typical command and control framework will provide several different clients. Now, in our case, because we're running Linux, we're going to download this Linux client, and this should save the file in our downloads directory. So if we list the contents of our download, the file will be there. Now, before we can use this file, there are several things, we need to perform on it. For one, let's just go into this download folder. For one, this file is currently not an executable. Right, so if you look at the permissions here of the file, it's only read, write. There's no executable permission. So to make it an executable and to actually be able to run it, we're going to use the chmod command with the X switch here, and simply providing the file here as is, it will make it an executable. So if we list that again, list the contents specifically of that file, now it's an executable. Great, so with that done, the other thing we need to do is, to avoid starting Sliver client from the downloads directory, we will add the executable to one of the directories in our paths. So if we list the path contents here, you'll see that several directories exist for the system path. And if you've never heard of the path before, essentially it provides the system a place or an area to search for executables. So what we're going to do is we are going to copy Sliver client Linux to the user local bin directory. right? And what this will do is it will allow us to, again, run the Sliver client from anywhere within our path because it's in our path. And before we copy it directly into it, we're just going to remove that underscore Linux thing because, that's quite tedious typing that in all the time. So with that copied, our permissions are denied. We need sudo permissions. So just use sudo here, and there we go. So if we go back into our directory and run Sliver client here, you'll see that an error message will appear, but we need a server setting up prior to running our client. Now, installing the server follows a very similar process. We're going to need a executable or binary. You'll need to select one that is applicable with the operating system for which you are installing the server on. So you've got Linux, you've got Mac OS, you've got Windows, but the developers themselves actually recommend that you install it on Linux. And because we are running Linux, we're going to right click this, select copy link. Then we're going to go to our server, and to download it, we'll just simply use curl with the uppercase L switch to follow any redirects and the O switch to save it as a file. And we'll just name this Sliver server like so. Now, once the file has downloaded, if you list the contents or if you just list the file itself, you'll also notice that the file is not an executable. So we'll just use the chmod plus x command to make it an executable. And when we run the server, we're not just going to run it as is, but we're going to use the H switch to list its usage. Now, the Sliver server itself supports various different commands. You've got the version command to list the version for which the server binary is for. You've also got the unpack command for which unpacks all of the server's assets. You've also got the operator command, which generates operator configuration files. And these are used, when you're running in multiplayer mode and you're distributing configurations per operator. And lastly, you've got the daemon command, and this command basically starts the server in daemon mode. Now, before we can actually run any of those commands, we're going to need to unpack all of its assets. So just use Sliver server unpack, and then also you can use the force switch to override any existing installations should you have any. So let's run this. And once the assets have finished unpacking, if we were to run Sliver server, we'll be presented with a Sliver server's prompt. Now, one thing to note, before we proceed, is make sure you're installing the server under the root user. Otherwise, when you start your listeners, if the server was installed under the context of maybe just a standard user, some listeners won't start. For instance, the HTTP listener, for which we'll see later, by default uses port 80, and without the root account, we won't be able to listen on that port. So just keep in mind, when you're installing the server, use the root account. Now, if we go back to our client machine and try to run the Sliver client command, you'll notice that a error will appear indicating that no configuration files were found for the client. Now, this happens because of the way we set up the server. Because the server itself is hypothetically running on a remote system somewhere in the cloud, quote unquote, every single operator that connects to the server will need its own configuration file. Now, to generate this configuration file, we'll go back to the server, and by running the Sliver server operator command with the H switch, we'll see the options that Sliver server needs to generate one of these configuration files. So most importantly, we'll need to specify the listener host, and this will be the IP address for which, as an operator, can reach out to. In this case 10.0.8.25, and also we'll need to give it a name, so we'll just simply use sunflower. Now, optionally, you can specify the S switch to save the file to a specific directory, so we'll just save it in the temp directory because we'll be transferring the file over later. And also you can specify a custom port using the P switch, but by default, Sliver server runs on 31337, so that's fine. We can leave it as it is. So running the command, you won't get any output, but listen the contents of the temp directory. You'll notice there that our specific configuration file has been generated. Now, if we were to go into that directory and actually list the contents of that file, you'll notice here that the file is originally in JSON format. So you've got all your configurations here, such as the token for which the client will use, the IP address for which the client will reach out to connect to the server, the L port or the listening port of the server, and the list goes on. Now, if we look at the permissions of the file, you'll notice that it's actually readable by the root user, the root group, and everybody else. So what we'll do is we'll go back to our client machine. We'll go to the Sliver client.configs directory here. And if we list the contents, notice that nothing is present, but by using the scp command, we'll be able to transfer the file that is in the temp directory to our current directory here. So if we run that as it is, list the contents, and the configuration file is present. Now, if we go back to our home directory and try to run Sliver client again, you'll notice that it attempts to connect to the server, but we've actually not started the server up just yet. Now, back on our server, we'll run the Sliver server binary again, but this time we'll run it with the daemon command. And if we list the help menu for this, you've got several different options for how you might want to start the daemon. Now, we'll simply run it as it is, like this, and the daemon will start. And if we go back to our Sliver client OS again and run it as is, now we'll be able to connect to the server. Now, we've set up the client and the server separately, but if we go back on the server, you'll notice that the way we start the server is quite tedious. Now, because we're running the Sliver server daemon command every time the server restarts, or every time we terminate like this, we'll need to start the daemon once more, like so, to be able to connect to it. Now, I challenge you, the viewer, to make this into a job that starts automatically once the operating system boots up, so then you won't have to manually start the server in this way. So now, with the server and the client installed, when the client is launched for the first time, you'll be greeted with Sliver's prompt. One of the most fundamental commands here is listed, and it's called help. When you run this command, you get a list of all of these supported commands by Sliver. So you've got your base commands here, such as clear to clear the screen. Then you've got exit to exit the shell. Monitor to set up some monitoring for threat intel platforms for all your Sliver implants and more. Now, one of the most fundamental aspects of Sliver is its implants, and the implants are the payloads that are generating using Sliver and delivered to the target systems for remote control. Now, to generate an implant is done with the generate command, and typically you'll be able to specify the type of implant you're generating, and in Sliver there are two. We'll discuss these shortly, and then also you'll specify the type of connection you'll be establishing. Sliver supports several of these. We've previously touched upon this. Sliver supports mTLS, HTTP, HTTPS, DNS, and much more. Then, you'll also want to specify the address for the command and control server, and also the format and the architecture of the implant. Now, we'll get into actually generating an implant shortly, but it's worth noting that Sliver implants come in various different forms and types. Some of those are executable via the command line, and others are loaded as additional libraries into existing programs. Now, the choice of these types of implants that we will be generating will typically depend on the target system we are attacking and the capabilities at the time of deployment. So what this means is, say for instance, we're performing a phishing attack, and the only way of actually getting our implant executed could be maybe through a Microsoft Office document. Then we'd have to tailor our implant, and that would be done using stages, which we'll discuss in the next video, to apply, to the capabilities available to us. Now, as we just said, there are two types of implants. You've got the session implants, and then you've got the beacon implants. The session implants are perhaps one of the more basic implant types because they establish a real-time bidirectional communication channel between the agent and the command and control server. Now, there are some limitations with session-based implants, but typically, these types of implants make continuous connections back to the command and control server, which, suspecting blue teamers can quickly pick it up and, block it. So to describe the, procedure of session implants, you can see that in the diagram there, I've outlined the three components of a command and control framework. You've got the client, the server, and the agent. So first, the client generates the implant and delivers it to the victim. The victim then executes the implant, and the implant makes a connection back to the server. And during this time, the implant can perform key exchange, to establish a secure and covert channel. Now, upon negotiation, a bidirectional communication channel will be established between the agent and the server. And as we said, these types of connections, while they're really good, for continuous execution and, obtaining results back from the agent in real time, they lack that kind of stealth behind them. Another implant type is the beacon implant, and these types of implants, rather than sustaining a continuous bidirectional communication channel, instead they operate at specific intervals, often with added randomization through jitter. And jitter is perhaps one of the best features of an implant, because it allows us to add another layer of obfuscation through randomization, where a jitter will add upon the existing interval, where it will determine a random value once we give it a value. So say, for instance, we have an interval of 30 seconds. And then on top of that, we add a jitter of maybe 5 seconds. Now, what the jitter will do, it will wait upon the original interval of 30 seconds, and then it will decide itself between the 5-second range, whether it wants to add another 2 seconds, 3 seconds, 4, or maybe even 5. So you could probably see how much more stealthier this could be, because of not only operating at specific intervals, which could still be pretty easily picked up, a jitter further obfuscates that original interval time. So in this case, as the previous image, stages 1 to 3 remain the same. However, from stage 4 onwards, the implant will wait a predetermined interval before executing, and once that interval elapses, the implant will initiate a connection to the server. Then it will check for any pending commands, or also known as tasks, and then it will execute those commands, then transmit the results back to the server, and then it will terminate the connection, and it will return to its dormant state. So overall, when you're working, in a real world scenario, for an actual organization, performing a red team for an organization, typically, you'll be using beacon implants purely because they're a lot more stealthier. So where a session implant generates a continuous connection, a beacon implant will do so at specific intervals. Now, to generate an implant, we use the generate command. And in case you want to list the various types of options it supports, you can use the help command prefixed. So if we list the various types of switches available here, you can specify a custom architecture for your implant. You can enable certain features such as debugging, or you can disable certain features such as shikata ganai, shellcode encoders, and the list goes on. So I'd suggest that you have a look through the various types of options that Sliver supports and get to know them. Now, just to note, some of these options have default values. By default, the implants that are generated with Sliver will be generated for Windows-based systems, but in case you want to specify a different type of format, for instance, you can use the F switch, and then you can specify a custom format for which the implant should be generated as. Now, at its most basic, the generate command will need a listener to connect back to, and we'll get into listeners shortly, but in our case, we'll use mTLS for the remainder of this course. So we'll specify M, and then also we'll specify the IP address of the server. And this is the IP address that is exposed to the client and not to the operator. And then also, we'll need to specify the location for where we are saving the implant. And we'll save it into a directory called payloads. And just before I forget, I'll create a payloads directory here and cd into here. And then also, should you want to, you can specify a name for the implant, such as HackerForce EXE or whatever. Also, you can leave it, omitted to use Sliver's own word list, which I'll showcase in a minute. Now, additionally, you can specify the L switch to disable symbol obfuscation. And this is useful to basically just speed up our implant builds, and it's not really a useful feature for us as of now. So once we click enter, you'll notice that Sliver will generate a implant. It will give it a name. In this case, it is Comfortable Therapist. And if we go into our payloads directory and list of contents here, we'll be able to see that the file is indeed here. Now, to confirm that the file is indeed for Windows-based systems, we'll use file. And we'll supply it with the name of the executable. And if you look at the output here, you'll be able to see that Sliver indeed generated an implant for Windows-based systems. Now, what we generated here is a session-based implant. To generate a beacon-based implant, not really much differs, but you'll need to specify a beacon argument following generate, and also you'll need to specify either a value for the seconds for which the beacon will have an interval of, or you can specify hours, or I believe also days. So you can really go crazy on the type of implants, but most importantly, the jitter is what we're also after. So to generate a beacon-based implant, much of the values here will remain the same. We'll just specify beacon here, and also we'll specify a second value of 45. By default, I believe it is 60, and also we'll specify a jitter interval of 15 seconds. So once generated, not much differs. But essentially what we've generated now is a beacon-based implant. So if we go back to payloads, and we use file for both of the executables here, they are identical, but one of them, institutional clover.exe, is a beacon-based implant, and then comfortable therapist is a session-based implant. And that is essentially how you generate implants in Sliver. It's pretty simple. The most confusing part is really getting to know the switches that are supported. So again, I'd recommend that you have a look through the switches for the beacon-based implants and the switches for the session-based implants to really get to know how these implants are generated. Now, before we continue on to what listeners are and how to create them, and subsequently how to catch connections with them, I just kind of want to show you how Sliver generates its implants. That is the names that are used to generate the implants. Now on the server, if we cd to the Sliver directory here and list its contents, you'll notice that one of the files here is named adjectives and the other file is named nouns. So if we list the top 5 adjectives here, the adjective will be used first and then the noun will be used. So we'll supply nouns.txt here, and there we go. That is how Sliver generates its implants. Listeners are those things on Sliver that you set up to catch a connection from the executing implant. And a listener is simply a designated port that will be set up on the server to essentially manage the communication channel for its configured protocol. Now, every single implant that you create will require at least one listener to connect back to, and a listener can simply be made using its respective command for the type of listener it is. So as you can see there, Sliver supports 6 in total. The HTTP and HTTPS is different, and the listeners are different. They have different values, but it's pretty simple. For a DNS listener, you'd simply specify DNS. For an mTLS listener, you'd specify mTLS, and the list goes on. Now, one thing with Sliver is that, multiple of the same listeners are not required, and also that would be impossible. And the way it manages the listeners allows multiple of the same implant types to connect back to the server and use the same listener. Now, we'll get into, actually seeing, how this works shortly. But if in case you're using one of those default ports as your maybe payload hosting server or something like that, you can change the port that a listener listens to using the L or L port switch. But by default, it will use its own port. Now, in this video and all the subsequent videos that are to come, we're going to use the mTLS listener purely because it's easy to use and sufficient. The note is that mTLS, while it's great for practice, it may not always be great, in organizational environments. And in our actual course that we are writing, we go into all of the different types of listeners you can create. So you go through setting up a DNS listener, HTTPS listener, and the lot. But for this mini course, mTLS will suffice. So when we run mTLS, you'll notice that Sliver will report back to us that it successfully started a job. And a job is, well, essentially a listener. To view all the listeners, or as Sliver calls it, jobs, we'll simply just run jobs. And by doing so, you'll notice that Sliver will list the different listeners that were previously created. Now, in case you wanted to change the port, remember I said you can do this by specifying the L switch, and mTLS uses port 8888 by default. So say for instance, you were setting up several of the same listeners, you'd simply specify a different port. So we'll just use 9001. By doing so, you'll see that there will be two jobs now. One listener for mTLS listening on 9001, and then the other listening on 8888. Now, another thing I want to note, a listener can be made persistent. And what I mean by this is, every time the server will start up, the server will require you starting a listener manually. So every time, our server goes down or something, we will need to specify a listener once more. And this can be avoided by simply using the P switch. So let's just use a different port here. We're going to use 1337. And by specifying P, it will make it a persistent job. So if we list jobs now, every time that Sliver starts, no matter what happened to it, maybe it went down or we just restarted it, this job will start automatically. Now, for a complete overview of the commands and options available with jobs, we can obviously use help, prefix help with the jobs command, and by doing so, you can get some more information on the jobs that you can configure. Now, there will come a time where you might want to terminate a job, whether you may be done with the listener or whatever the case may be. To do so, you'll simply use jobs with the case with the switch K, and then you'll specify a listener. And if you notice here, every single job gets a listener. So this first one has got the first listener that we created will get the ID of 1, and the same will apply for the second listener and the third listener. So let's say we want to kill the first job, we'll simply use K with the value of 1. And if we list jobs again, you'll notice that the listener is now gone. Now, to clean up altogether, if you've got multiple jobs, maybe 10, 15 or 20, you can use the uppercase K switch, and this will remove all the jobs from our Sliver server, so we'll have no more jobs whatsoever. And that is essentially everything that there is to do with jobs. Just remember, for every implant you create, it will require a listener to connect back to, and listeners can be made using the mTLS command or HTTP command, depending on the type of listener you're creating. So always ensure that a job is present, because you don't want to be executing an implant and then having a job not set up, and you can potentially lose that chance of executing your implant for the first time. So in case you want to avoid that, just set up a persistent job so it's already out of the way for you. So now that we learn, how to generate implants and generate listeners, comes the lesson on actually obtaining and handling a session. So what you can see here is I've obviously started an mTLS listener, and I've also created 2 implants. One of those implants is a session implant, and then the other is a beacon implant. And remember, the way we specify whether an implant is a beacon or session is by using this beacon argument here. Now, if we go back on our target machine, don't worry too much about how we've uploaded these 2 implants at the minute. We'll actually go through a video, explaining on how you can deliver implants to your targets when we discuss phishing. However, for now, as this is a demonstration, it doesn't really matter. So with these 2 implants on the system, what we're going to do is we're going to execute them. And Windows will prompt us saying that, this publisher is unknown. Are you sure you want to run it? Yes, we are sure, Windows. So we're going to run both of these implants. And if we go back onto our attacking machine, what you'll notice is 2 new connection strings. One of those connection strings is for our beacon, and the next is for our session. Now, reading the implants is pretty straightforward. We've got an identification on whether it is a beacon implant or a session implant, and then every single implant will also have a specific identifier, its name, the IP address of the target system, which in this case is 10.0.9.11, a host on Active Directory, and then obviously its host name alongside of it, and then an identification on what system it is, what architecture it's running, and the time the connection was obtained. Now, listing the sessions and beacons is done differently. So for sessions, we've got the sessions command, and if we run that, we'll get several columns here specifying the ID of the beacon, the transport it's using, the remote address, the host name, the username, and the lot. Now for beacons, it's pretty much the same as sessions. It's just the beacons command, and you'll notice here an additional column for the when the beacon was last checked in. That is when the beacon last checked in to see if there are any jobs for it, and when it's next due to check in. So in this case, it's 10 seconds. If we run beacons command again, you'll notice that the beacon attempted to connect to the server, but obviously we've not given it any new commands, so it will continue doing so. Now, to interact with a session or beacon, we use the use command, and also we specify the ID of the beacon, not the name. So the ID in this case will be 62, and you can use the tab key to autofill the beacon as well in case you need to, which avoids having to type the long string there. So once we click enter, you'll notice that we will enter the beacon, and this will be where we execute our commands from. So if we list help, Sliver will present the various commands that it supports, and we'll get into this a lot later in our mini course. It's not really important for now, but obviously if we run the info command, you can see a lot of information on the beacon itself. So you get the beacon ID, the name, the host name, and this is one of the commands that is used for enumeration. Now, don't worry if you don't understand any of this output at the minute. You don't really need to focus on this. What we're focusing on is actually using the beacon itself. Now, remember, the way beacons work is through tasks, and tasks are essentially the command that the beacon will fetch periodically, with the server. So if we say run the command such as ls, this will be scheduled to run as a task. Now, to view all tasks, you can run the tasks command, and here you'll see several columns that highlight several important fields. So you've got the ID of the task. Here you've also got the task state, which basically outlines whether the task is still pending or has completed. Then you've got your message type, so this is essentially the command we are sending to be executed. Also when the task was created, when the task was sent, and also when the task was completed, if it were completed yet. So when the task completes, you'll notice here the Sliver will report on which task was completed for its ID, and then the task itself, such as ls in this case, was tasked to list the contents of the directory that we were in at the time. Now there are several task-based commands, so if we list help tasks, you'll see several different options that you have for your tasks. So one of those commands here is fetch, and what this will do is it will fetch the task that we give its ID for. So for instance, let's execute ls again, and then you notice that it gives us the ID, and if we do tasks fetch and provided that ID 27586, it will list the information about the task. So here, you've got the request size, how big the task is, and also when the task was created, a little description, and whether it is still pending or not. Now, another feature of the tasks is its cancel command, but we've noticed that strangely enough, it doesn't work. So if we, get a task running, we've got tasks cancel, provided it's BD08, provided its ID, notice you'll get a RPC error that we've provided an invalid beacon task ID. I'm not really sure if this is a bug. Maybe the developers, if they're watching this video, can inform me, but typically you'd be able to cancel your task provided its ID. Now, one of the more interesting features of beacon implants is that they can be made interactive. And what I mean by this is that beacon implants can be transformed into session-based implants by running the interactive command. So if we list the help for this, essentially you can see there in the description it's got task a beacon to open an interactive session, and then we can specify additional flags should we need to, such as maybe a different listener or maybe a timeout, whatever it may be. So let's run the interactive command, and this will task the beacon to run the interactive command, and we can actually fetch this to see some more information. So 7913AF41, and then here you can see the description is to open up a interactive session. So here you go. Once it's executed, you'll see another connection string, and notice this time it will be given a name of session, also a new identifier, and those other strings that we had here. So to use that session, we can either use it directly from the implant we have, like so, and then provide it its ID, or we can also background the current implant using the background command, and then using sessions, list the sessions available, and then provide it its ID here. So 607, and there we go. So at the minute, we are within a session-based implant, and basically everything that applies to a beacon-based implant applies to a session-based implant. But you'll remember that session-based implants are, bidirectional, and they, happen in real time. Their connection is in real time. So we've got no such thing as tasks. So every command we execute, info ls, will happen in real time. Now at the minute, if we list our sessions using the sessions command and beacons using the beacons command, you'll notice that we currently have 2 sessions and 1 beacon. Now there'll come a time where you might want to remove the current sessions or beacons, and to do so is pretty simple. For the sessions, you'll simply use the sessions command and you'll specify the K-switch. And then also you'll want to specify the ID of the session you are removing. So in this case, 607BFCAC, and that will kill the top session there. So you'll notice after we terminate the session, Sliver will report that it's lost connection to it. Now, one other way to kill sessions is to basically just use sessions uppercase K, and this will kill all the sessions that are currently active. So running this, you'll see also that the one we've used for testing was also terminated, right? So this is just one useful way to terminate all existing sessions after you've finished an assessment or whatever it may be. Now for the beacons, it's pretty much the same. We'll simply use the beacons command with the K-switch followed by the ID of the beacon that we want removing. And one thing I want to note here is that you can't use tab autocomplete here. So if we click tab here several times, you'll notice that it doesn't autocomplete. And in this case, you'll just have to type out the short name for the implant, which is the ID value right here. So if we click enter, you'll notice that the beacon was killed, but strangely enough, you might wonder, well, the beacon is still there. Oh yes, the beacon is still there, and the way to permanently remove it, we'll have to use the beacons rm command. And once we execute this, it will prompt us to select the beacon we want removing, and if we select this, you'll see that the beacon has now been removed. Now there is an additional command called beacons prune, and what this will do is it will remove all stale beacons automatically. And a stale beacon is essentially a beacon that has not reached out to the server for a given time to fetch a command. Now, as we've not got any beacons, I can't really showcase this, but essentially when a beacon will have its last check-in time that is over the limit that we've specified it, by running beacons prune like this, it will prune the beacons that have missed their last check-in for over an hour or more. Now, one of the last commands I want to show you is the settings command, and basically this command manages all client-side settings. So if we list help settings, you'll see here that we have various different options for managing the way our tables are presented, the small terminal, the way basically the terminal is presented, where the current settings are saved to disk, and much more. Now, say for instance, we want to modify the way tables are presented, we'll simply use help settings tables, and you'll notice here there really isn't any flags that we can specify it. So if we run the command like this, we'll be given to select the style, the way the tables are presented. So let's say style colored black on blue white, and the settings should take place now. So say for instance, we just ran settings. There we go. You'll notice the table appears in a much more vibrant manner. Now, I recommend you have some fun with this. Try to change the settings to your likings, but essentially what we've covered in this video sets you up for the next to come. So I really hope you've learned something new. In this video, you've learned how to, set up implants, set up listeners, and basically navigate and use a command and control framework. Now, if you've made it all the way up to the end of this video, it's a pretty big achievement. I know this video was quite long, but in the next video, we'll discuss what stages are before moving on to, reconnaissance, phishing, and all the good, exciting stuff. It's been your host, mTLS, and if you enjoyed this video, make sure to leave a like, and I will see you in the next one.